Okay. Okay, let's start.
Okay, it's time to start, guys. Okay, so welcome back, everyone.
Woo!
It's another week of Level 2 Games Workshop, and for this week, both Unity and Godot side will be going through finite state machines and the basic design of enemy AI in games. So, what is game AI?
Can someone tell me what's game AI?
Artificial intelligence, modeling the behavior, ChatGPT in your computer. Okay, interesting propositions, but in most cases, when we say about game AI, is just about trying to model a behavior of some kind of character that is present in the game. So it's supposed to make the game feel more interesting. If you look at it, like Minecraft villagers, they look pretty boring, right? But when you look at more like AAA titles, you have the NPCs that can give you proper dialogues. They have actual movement, and then they can kind of have some kind of behavior. They give you quests, and everything of that sort is what we call game AI. So what you want to do with this AI is you always want to define behaviors for that game entity. So, and the behaviors should at least be distinct from one another. You don't want to have like two NPCs of different types to have same behavior. Then it doesn't make the game feel interesting. They should at least have distinct behaviors, stuff that are unique to them, etc. And it is also more commonly known as bots in a lot of other games. Like if you play Counter-Strike, there's like code versus bot, code versus AI. So these are also the same kind of AI. Yeah. So how AI is being implemented in most of the games out there right now is what we call a finite state machine. Of course, there are different ways, but finite state machine is the easiest and the most straightforward way that you can implement a game AI. And what a finite state machine is essentially a coding, like some kind of programming pattern that you can do. And what you do is that you define multiple states for your AI. So states as in things, as in what kind of behavior they should be doing at this current moment. And then you define the specific behavior for each one of the state. Then you can define the transition condition for each of the state. So imagine, say, is a human. I'm walking around right now. So walking can be a state. I'm talking can be a state. I'm standing still can be a state as well. So you can define as many states as you want, as specific as you want, as long as every state carries a purpose and it changes the behavior of what the AI or the NPC is currently doing. Let's take a quick example. It's a Minecraft zombie. I'm pretty sure everyone here plays Minecraft before. Like, who doesn't play Minecraft? Who hasn't played Minecraft? Okay, it's the iconic game of the century, right? So, this is a zombie, and the most basic kind of behavior that we can extrapolate from the zombie is that, one, it moves around mindlessly. So after spawning, it's just going to move in any random direction that it wants to. And then it's going to chase after the player when it sees you. So when you are within a certain range to it, a certain distance to it, and then his eyes or his head is rotated towards your direction, it's going to chase after you. It's going to chase after villagers when seen, is about the same thing as players, just that the target is now a villager. It attacks the player or the villagers when it is close enough to the player or the villager. Usually within like 1 or 2 blocks if we put it in Minecraft unit, right? And it dies when the HP reaches 0. So these are the few states and the few of the behaviors that we can define in each state. And so in order to model this into a finite state machine, the easiest way is we can draw a state diagram. If you have taken 210 or you're taking 210, this would probably be familiar to you. So what this state diagram is essentially you always start with an entry point. Okay, do I have a laser pointer?
Where is this in 210?
This should be in the second half of the semester actually.
This is the first half.
Okay, so you always start with this entry point here, which is this black dot. So you have to define a behavior that the entry point transitions into. So in this case, the entry point transitions into an idle state. So the idle state is probably just going to let the zombie stand still. It's not going to let it move around. And on random intervals, this idle state is going to change to a patrol state, such that it can allow the zombie to move around in random directions. And after a set random interval, it transitions back to an idle state. Then we can see that when the player or the villager is in sight, it's going to transition from either patrol state or idle state into an aggro state. So when we do this, we also want to define the aggro behavior, which is to set its movement destination towards the target, and then it's going to move towards that target. Then, if the target goes out of sight, it's going to transition back to the idle state. So this transition is like a two-way transition. And after that, when we are in the aggro state, if the target is close enough in its attack range, it's going to transition from aggro to attack. This attack state here is going to be like a trigger state. So it's only going to trigger once, and then once the attack state is over, which means the behavior where the attack is going to be done, which is do damage, right? It's going to transition back to the aggro state so that it can chase the target again. You can define several different transition behaviors for that. For example, there must be a cooldown, and after a set cooldown only then it can transition back to the attack state, etc. So after that, we can see that HP, when the hit points is smaller or equal to 0, we want it to die. And die can be its own state, or you can just set it as an exit state. So from any state here, once the HP reaches less than 0, it's going to die. This means that you can technically one-shot the zombie without it going into aggro mode as well. So this is how you can design a bare-bone finite state machine. And this is quite a simple one actually. Is everything okay so far? Yes? Yes? Okay, cool. So in terms of actual implementation, since both Unity and Godot is here, we won't be going through like the actual code for it, but we'll be going through some pseudocode as to how you can do it. Essentially, you should define the states as either an enum or inside of a dictionary. This is so that it's easy for you to maintain, and it's also easy for you to refer to. So the states can have very self-explanatory names, which is exactly the same as how the state should be named. And you can perform the state behaviors in the update loop. So you want to make a check to see which state the zombie or the NPC is currently in, and then you can perform its behavior in that particular update loop. Then you can perform the state transitions inside of the state behavior. Notice that in this particular finite state machine, not every state can go to every other state. So you probably don't want to have the transition logic in the main update loop, because if you do that, this means that whichever state that the zombie is currently in, it can change from idle to attack or from patrol to attack or vice versa, which is not a very good design. So instead what you want to do is to change the transition conditions such that the attack check is only inside aggro. So it's going to have an if else check inside of the aggro state to see if it's inside of the attack range, etc. So yeah, and if you look at it in pseudocode, it looks something like this. So you have a set of enums, which are the states that are available to the NPC. And then you have a loop, which is going to be your main update loop. And there's a switch case here. So if the state is idle, then it's going to call the idle function. If the state is patrol, it's going to call the patrol function. And for the functions themselves, they can do whatever behavior that you want it to carry out. So we can do a quick activity here. We can try to design your own AI. For example, here is the skeleton AI from Minecraft as well. It has several kind of behaviors to it. The first one is that it moves around mindlessly, same as the zombie. And then it walks into shooting range when the player is inside. It shoots the player when it is in range. It shoots the player after a set interval. It moves away from the player if the player is too close. And it dies when HP reaches 0. So, actually, I think, yeah, so if you're interested, you can try to design this finite state machine. Anything else? No. Okay, cool. So, once you design it, you can call us over. We're gonna check it and whatever. But aside from that, I'm pretty sure that's it for today's slideshow. So, any questions?
Questions?
What do you mean by design?
Yeah, you
Design
just
means
draw a
a
state
diagram.
machine.
Okay.
You just draw a state machine diagram.
Then
Something
also
like-
one more thing. This skeleton specifically tries to find shade in the sun.
Yeah, just the skeleton, because it's quite a simple AI. So that it would be a very good practice for you to figure out before you move into more difficult and complex state machines. So the state machine diagram looks something like this. You have the states as each block. You can transition from one state to another, and it has the transition condition on it. And then there's also an any state node that you can go into either
Okay,
entry or
anyone
exit.
not clear about how to translate this to code? Okay, great. Okay, let's go.
Okay,
back to
cool. So, yeah, this is the skeleton AI, and yeah, you can try to model it. Okay, aside from